vibrant vitality and unlimited creativity. Bodor embarks on the journey of embracing laser dreams. From traditional industry engineering to emerging realms, from home appliances to heavy equipment, Bodor delves into the world of lasercraft. The brightest light shapes the dream from heart. Each venture starts a breakthrough anew. Since Bodor's inception in the laser industry, its course has been destined to infuse life and change. From research and production to global sales and service, Bodor focuses its strategy on laser cutting and welding machines. When creating its revolutionary laser scanning cutting new category, the pioneering spirit on innovative technology takes the stage and brings fresh opportunities for industry growth. With multiple top global awards, Bodor's design is acclaimed, continuing to lead the industry trends. Each stride pushes excellence forward. Through focused research on core optical components, the high-standard clean workshops achieve dust-free production of laser heads and laser sources. Standardized and refined production processes, along with quality inspection procedures, ensure consistent product performance. Through dedication and self-reliance, Bodor leads in building a laser ecosystem with 6 self-developed core technologies. Through innovation and change, Bodor is always a step ahead. In the smart digital factory, 9 automated assembly lines achieve standard and efficient production, delivering 1 Bodor laser cutting machine every 10 minutes. Supported by world-class intelligent manufacturing systems and stringent quality management, Bodor is committed to offering top-quality products with no defects, driving industry transformation and advancement. At Bodor, craftsmanship and intelligent technologies make the excellent quality a consistent performance. Bodor Laser Machine cut all the Tokyo 2020 Olympic and Paralympic symbols on the victory ceremony podiums. Each step aims towards tomorrow's best. Bodor's global approach and high-level European standard attract top talents from around the world. In 180 countries and regions, its footprint reaches to hundreds and thousands of customers' plans to fulfill Bodor's belief in paramount service. Bodor is committed to establishing a global service network. This ensures quick response times and professional service for global customers. As Bodor steps to the world's grand stage, the fixated focus, the story's new page, will celebrate the coming realities. Bodor Laser has secured the top-ranked global sales volume leader for 4 consecutive years from 2019 to 2022. At Dream Park, the future global headquarters of Bodor, spanning 300,000 square meters, a gathering place of diverse...
Hey everyone, welcome to Bodor Laser Academy Live. I'm Dennis from Bodor Laser. Great to see you guys today. And let's take a look at these 3 pictures. Look familiar, right? It's the jaws build up, burnt edges, and slow cutting speeds. Inconsistent quality between operators. I think these are very common cutting defects when we do manufacturing. So today we are going to fix everything up. We are going to break everything down, what really affects your cutting results, and how to dial in your settings step by step. And before we jump in, quick heads up, we are hosting a very special sales live stream later this month with our biggest offers of the year. If you want to secure that exclusive webinar discount, just send global number 1 to info@bodor.com. We will email you the details ahead of time so you don't miss out. And let's check what you can get by purchasing Bodor laser cutting machines. By joining this giveaway, you can get accessories package value up to $5,000. And second, you can also get a free laser head. You can also get handheld welding machine, which is our Air series and Alco series and Pro series. So all right, let's bring in today's guest, Frank Vitali.
Hi, Dennis.
Frank Vitali is our innovation engineer here at Bodor. He has been in laser cutting world for years, helping big manufacturers improve their production with laser tag. When it comes to cutting parameters, he is one of the best of there. Welcome, Frank.
Thank you, Dennis. Thank you, Dennis. Hi, everyone. It's really great to be here. I'm excited to share some very practical cutting parameter tips that you can start using as soon as you go back to your machines.
So, all right, everyone. Here's what we are going to cover today, and feel free to drop already in the chat if you are excited. First up, we will invite Frank to walk us through the key factors that really decide your cutting results. Things like laser power and focus position, and the nozzle choices, gas pressure and flow, and of course the cutting speed. And Frank is also going to break everything down in simple, practical way to you, so you will understand why each parameter matters and how to set it correctly. After that, we will jump over to the workshop and show you how there's some real cutting in action, so you can see exactly how these parameters behave on different materials. And then we will also look at some cool cutting technologies like marking, laser marking, and also countersinking, bevel cutting, air cutting, and also the very fast flying cutting. So you can see how these settings perform in actual production. And finally, we will wrap up with a very quick Q&A session if you have any question to ask for us. So keep your questions coming. Ready to dive in? Now let's type your questions in the comments. Okay, nice. I can already see that the chat is filling up with some questions. It's full of energy, and hey, don't forget to follow and share and like our accounts in social media. Bodor will give you anything you are interested in the laser cutting sections. And so, all right, then let's hand things over to Frank.
Thanks, Dennis, and thanks everyone. Before we go into the individual parameters, I would like to start from the basics. Once you understand what is actually happening during laser cutting, every setting, power, focus, gas, nozzle, becomes much easier to read and adjust. So let's start simple. What is laser cutting?
Well, that is a very simple question, basic question, right?
Yeah.
So can you break it down for us?
Yes, sure. Imagine a laser beam as a tiny, ultra-precise blade, but made of pure light. When that beam hits the surface of the metal, the temperature jumps to 2000 degrees in a fraction of a second.
Okay.
Yeah, and the metal melts or even vaporizes exactly along that path. At the same time, a high-speed jet of gas blows the molten material out of the curve. Yeah. And that combination, intense light plus high-speed gas, is what gives you that clean, accurate cut.
Okay, so basically, the laser does the heating and the gas does the cleaning, right?
Yeah, exactly. Exactly. That laser gives you precision, and the acid gas keeps the edge clean and smooth. And because the beam never physically touches the metal, there is no tool wear, and there is no mechanical deformation the way you might see with traditional cutting methods.
Yeah, that's very amazing. And laser is like a blade made of light, right? If you think that's cool, I think that's cool too. If you guys in the comments think that's cool, type cool in the comments.
I see. Cool. Yes, yes, it's coming. I have some. And that's just the warm up. Let's look at the two main types of laser cutting.
Yeah, I remember fusion cutting and also the oxygen cutting, right?
Yes, yes. Let's start with fusion cutting. Yeah, that's where the laser melts the metal, and nitrogen or clean air blows the molten metal away. Since the gas doesn't react with the metal, the cut surface stays clean, shiny, and no oxidation.
Oh,
yeah,
got it.
Yeah, perfect for stainless steel, aluminum, and titanium. Yeah.
I see. So, what about oxygen cutting?
Oxygen cutting, on the other hand, works almost like adding a flame boost. Yeah, the laser preheats the surface, and then oxygen reacts with the hot metal. The reaction releases extra heat, and that extra heat helps the laser cut faster through the metal.
Okay, so
Material.
yeah. So I see. So oxygen is basically make the cutting faster. And it's like giving the laser a turbo boost, right?
Yes, yes. That's why oxygen cutting is the ideal for carbon steel. Fast, is efficient, and low gas cost. Yeah, you can cut stainless steel with oxygen too, but the edge will be darker and rougher because of the oxidation. Yeah, so in most cases, we still recommended oxygen mainly for carbon steel.
To sum up, oxygen for carbon steel and nitrogen for stainless steel and aluminum.
Yes, that is the key difference.
Okay.
Yeah. Now let's move on. Let's move from how it works to how you control it. Yeah, the cutting parameters. Yeah, first up is laser power. Laser power is simply how much energy you deliver into the metal. Yeah, take a look at the screen. On the left, you can see what happens when the power is too low. The beam does not fully pressing, and you end up with the incomplete cut. In the middle image, the power is too high. The metal overheats, the curve becomes wider, and the edge turns rough and over-melted. On the right, you see the result when the power is set correctly. A smooth, shiny edge with no dross.
Oh, okay, I got it. And after power, I guess it's focus, right?
Yes, the focus decides where that energy is concentrated inside the material. If the focus is too high, the energy spreads before the energy spread before it reaches the core of the sheet, and the piercing becomes poor. If the focus is too low, you push the energy too deep, and you can burn or roughen the edge.
That sounds tricky to adjust manually by operators.
Yeah, that's why Bodor machines uses automatic height following. The system continuously adjusts the nozzle height for you.
Wow.
Yeah, so the focus stays in the right zone. Yeah, even if the sheet is not perfectly flat or the thickness changes across the plate. That means less manual fine-tuning and more consistent results from part to part.
Okay, that's more convenient. And I've seen a lot of users also ask about positive and also the negative and zero focus. So when do you use each one?
Great question, Dennis. Here's the simple version. Zero focus.
Zero focus.
The focus sits right on the surface of the material. energy is distributed in a balanced way through the thickness. This is common for medium thickness plates and gives very stable, clean edge. Then positive focus. Positive focus. Yeah, the focus point is above the material surface. The beam spreads slightly before entering the plate. This is ideal for thick carbon steel with oxygen because the wider curve makes it easier for the molten metal to escape. Yeah. Then negative focus. The focus point is inside the material. Yeah, you get higher energy density deeper in the sheet. This is ideal for stainless steel and aluminum with nitrogen, giving bright, clean edge, and reduces dross.
Okay, nice, but I think it's quite complicated. I can sum up right. It makes sense, but so the focus position always change the energy density, right? And it will also change how the metal form inside the curve.
Yes, exactly. You can think of it like aiming a flashlight. Yeah.
Flashlight.
Yeah, where you place the brightest spot completely changes the result.
Okay, I see. That's a very good explanation. And speaking of machine adjustments, I always see operators switching nozzles and gas settings. Do this really make a big difference?
Yes, a huge difference. The nozzle might look tiny, but it's critical. It controls the gas flow that clears the molten metal. If the nozzle is dirty, worn, or damaged, your airflow becomes uneven. Yeah, and even with perfect power and focus, your cut quality will suffer.
And nozzle size also matters.
Yes, exactly. Nozzle size matters a lot. Smaller nozzles create a faster, more concentrated gas jet, perfect for thin plates where you want a sharp, focused flow. Larger nozzles work better for thick plates where you need more volume of gas, even if the speed is a bit lower. The key rule is do not oversize the nozzle or the nozzle on thin sheet.
Well,
With too large a nozzle, you can disturb the cut and even risk damaging their lens.
oh, okay.
Yeah. You also notice two common nozzles, common nozzle structures. Composite nozzle, nozzles usually used for carbon steel cutting, and the single layer nozzles usually used for stainless steel. Yeah. Here is a chart showing recommended nozzle choice for different thickness of carbon steel and stainless steel. You can use it as a reference. If you like to see nozzle setting for other materials, feel free to leave a comment below.
Okay, chat. Feel free to leave us comments, and we will send you the nozzle setting reference. So it's definitely not bigger. The bigger the better, right, for nozzle?
Yes, exactly. Yes. Now let's talk about the assist gas. Yeah, it is just as important as the nozzle. For carbon steel, we usually use oxygen with a relatively low pressure for both piercing and cutting. For stainless steel, nitrogen is the common choice. And for thin carbon steel, stainless steel, or even some other materials, you can also use air. Yeah, the purer the gas, the better the cutting quality. So make sure your oxygen is at the least around 99.9% pure.
Okay.
Yeah, and your nitrogen is above roughly 99.9% if you want the very best results.
Okay.
Now, Dennis, let's do a quick quiz.
Really? Let's do it.
Yeah, take a look at this picture. Yeah, is this caused by too much gas pressure or not enough gas?
I think it's caused by too much gas pressure, right? I think there's a lot of jaws on the lower edge of the place.
I see many of you got it right. Nice job, nice job. This one is caused by insufficient gas pressure. When the gas pressure is too low, the cutting surface can show molten stains, and you are not able to increase the cutting speed, which affects efficiency. And okay,
the next picture.
Next picture. What about this picture? This is right. This one happens when the gas pressure is too high.
Okay.
Yeah. When the pressure is too high, the high flow becomes too strong, making the cut surface rougher and the curve wider. In some situations, that excessive airflow can even remelt part of the cut section, resulting in poorer cutting quality. Now, then is speed. It sounds simple, but it changes everything. Yeah. Too fast speed, you will get sparks shooting out and incomplete cuts. Too slow, you will overheat and melt the edges.
Okay. So how can our operators find the perfect speed?
Just watch the sparks. Normally, during cutting, the sparks flow downward in a smooth, slightly spread out pattern. That is the alpha state. If you see the sparks tilting to one side, it means the feed speed is too fast. If the sparks look narrow, no spreading and gathered together, that means the feed speed is too slow.
Yeah, I see.
Yeah. The ideal situation is when the sparks flow evenly as smoothly, and the lower part of the cut has no molten residue. That is how you know the cutting speed is just right.
Well, very good tips. So it's very visual and also very practical.
Thank you, Dennis.
Thank you, Frank.
And finally, remember that the sheet surface condition matters too. Yeah, matters too. If it is rusty, oily, or dusty, laser energy scatters and the cut becomes unstable.
Okay, so a clean and a flat sheet equals also a clean cut.
Yeah, exactly. Get all this right. Power, focus, speed, gas, and material. Yeah, and you will have perfect, efficient cut every time.
Okay.
Next, we have collected a few real cutting examples using nitrogen and oxygen. So let's analyze them together.
Okay.
Yeah. Here is the first one. This is an oxygen cutting sample. And as you can see, the cut surface looks quite rough.
Yeah.
Yeah. What do you think of this?
Well, I think let's check what comments say.
Okay.
I see some of the comments saying that the focus is too high, and others mention that the gas pressure too high.
Yeah, that's right. Possible cases include the focus point being too high, the gas pressure being too high, the feed rate being too low. Yeah, or the material being overheated. So organ fix. Organ fix. You can lower the focus position, reduce the gas pressure, increase the feed rate, or cool down the material.
Well,
now let's look at this one, a nitrogen cutting example. You can see plasma appearing along the straight cut section. What do you think caused this?
Well, still I can't say. Let's see what the comments say. Some of the comments saying that the cutting speed is too fast, and others also mentioned that focus position is not that right.
Yeah, that's right. And the other possible reason could be cutting speed is too high and the focus point too low.
Okay.
Or laser power too low. you can try slowing down the cutting speed and increasing the laser power.
So, all right, I think that's the end of the part to showing the cutting case analysis. So let's switch to next part. And in this section, we will show you some cutting demos in the factory. And here is what is going to happen. We will take a look at the real cutting shots and also a few special cutting technologies. So don't blink. This is where you can see the parameters turn into real parts.
All right. Before we start cutting, let's talk a bit about the machines we are using today. In laser cutting, power makes a big difference. The higher the power, the faster the speed, and the thicker the materials you can handle.
Yeah.
Here at Bodor, our machines cover a wide power range from about 3 kilowatts all the way up to roughly 60 kilowatts.
Wow, 60 kilowatts.
Yeah, that means whether you are cutting thin stainless steel, sheet, or even industrial plate, there is always a Bodor solution for that fits your job. Yeah. And for today's live demonstration, we are using two configurations. For carbon steel and stainless steel. We are working with a 12 kilowatt P3 for aluminum and brass. For aluminum and brass, we are using a 6 kilowatt C series machine equipped with the hour scan cut laser head, which gives extra stability when we cut highly reflective materials like aluminum and brass. And as we go through each material and thickness, we will also walk you through the recommended parameter setting, so you can see exactly what works well in real production. Okay.
So what materials do you guys cut most in your shop? And you can type your material types in the comments. Let's see. Well, I think I've seen that a lot of comments say that they are cutting carbon steels. So let's begin with that.
Okay, let's just start with carbon steel. Today we will look at two representative cases. One for thick plate, for thick plate, and one for medium thin plate. And we will use both positive and negative focus so that you can clearly see the difference. Right now, what you are seeing on the screen is a 16 millimeters carbon steel plate cut with a positive focus. For this cut, the focus position is set to about plus 14. We are using oxygen as the hazardous gas and a single layer nozzle with a diameter of roughly 1.4 millimeters. These settings give you stable cutting performance on thick carbon steel. Take a look at the sparks, falling straight down, clean and steady. That is exactly what you want to see. Yeah. When the sparks drop vertically like this, it means your parameters are dialed in correctly. Good piecing, a clean curve, and a bright, smooth edge. And all right. Now let's switch to a thinner plate, a 10 millimeter carbon steel sheet. It is the same material, but we are changing one key parameter: the focus.
Yeah, the focus.
The focus. Here we are using a negative focus set to about -8. And we are switching to hair cutting with a single layer nozzle of roughly 5 millimeters in diameter. With this setup, the cutting speed is in the range of about 5 to 7 meters per minute. Take a look at the sparks. They are shorter and more concentrated now. That is exactly what negative focus is supposed to do. By pushing the energy deeper into the plate, the molten material is cleared out faster. And look at the edge. bright, clean, with almost no dross at all. That is very solid result for 10 millimeters carbon steel using air cutting.
Okay.
Yeah. All right, moving on. Now it is time for stainless steel. I know many of you cut stainless every day, so this one is definitely for you. We are working with a 10 millimeter stainless steel sheet, and this time this time we are switching to nitrogen as the acid gas. And why nitrogen?
So why nitrogen?
Why nitrogen? Because it keeps your edge clean, bright, and free from oxidation. No burn marks, no dark edges.
Okay.
Yeah, for this cut, we are using a negative focus set to around -10, a single layer nozzle of roughly 5 millimeters in diameter, and the nitrogen as the cutting gas.
Okay.
Take a look at this edge. See how smooth and shiny it is? That is exactly what you want when you are making decorative panels, kitchen equipment, elevator components. Anywhere the appearance really matters.
Yeah, it's very common in our daily life.
Yeah, we are running at around 6 to 8 meters per minute. And if you look at the sparks, they are smaller, tighter, very controlled. That is the perfect sign of a stable nitrogen cut.
Okay, so it's very beautiful and looks like a mirror finish. Anyone here cutting stainless steel daily? So type stainless steel in the comments if that's you, and let's see how many stainless steel experts we've got watching today.
I bet the chat is fully of stainless steel right now. And here's a quick tip for you guys. Make sure your nitrogen is high purity, at least 99.99%. Yeah, that's the secret to getting this kind of glossy silver edge.
So pure gas and plus right parameters and clean sheets, that's the recipe for stainless steel perfection?
Yes, nitrogen plus proper speed plus stable focus equals that flawless cut. Simple formula, big results.
Yeah, it's quite simple.
Yeah. All right, now let's move on to something a bit more challenging. Aluminum.
Yeah,
Aluminum. Yeah, aluminum looks beautiful when it's done right, but as you probably know, it's also one of the trickiest materials to cut. We are working with a 12 millimeters aluminum sheet, and for this demonstration, we are using a 6 kilowatt C-series machine equipped with a scan cut laser head, a single layer nozzle of about 5 millimeters in diameter, a negative focus of roughly -8 millimeters, and the air as the acid gas. Yeah. For aluminum, the combination of nitrogen and scan cutting is a great choice, especially because aluminum reflects a large amount of laser energy. Keeping the focus stable and the gas flow clean, and the gas flow clean is absolutely critical to getting a crisp edge without burn marks.
Yes.
Yeah. Take a look at the sparks. See how they are shorter and wider? That is a sign that the reflections are being handled well. And look at the edge, bright, clean, with no burns at all.
So that's really satisfying to watch. For aluminum and some reflective materials, when we do laser cutting, it's common to say that these materials can do very huge damage to our laser source. And the scan cut laser head you just mentioned, this technology is innovated by Bodor Laser, and which is designed to solve the problems of laser cutting reflective materials like aluminum. So it's just when we do the combination of nitrogen and scan cut laser head, you can get a very smooth and bright cutting results of aluminum.
Yeah, so once everything tuning correctly, the laser basically glides through. And here is a quick tip for everyone watching. When you are cutting reflective materials like aluminum, make sure your protective lens is spotless. Any reflection or dust can throw off the beam, and that is something you definitely want to avoid.
Yeah. So good point. And anyone here working with aluminum in your shop, so just drop AL in the chat if that's you, and let's see how many aluminum pros we've got today.
Let's see the comment light up. All right, the aluminum cuts. All right, the aluminum cut looks great. Clean edge, consistent color. Yeah. All right, time for the grand finale, brass cutting. This one is always a crowd favorite. Shiny, smooth, and full of color. We are cutting a 10mm brass sheet using the same 6 kW setup with the scan cut laser head, a single layer nozzle of roughly 5mm in diameter, a negative focus of about -9mm, and the nitrogen as the acid gas. Brass under a higher power laser always looks stunning, especially when scan cutting is handling that highly reflective surface.
Yes.
Yeah. Watch the sparks. See that bright golden glow?
Yeah.
That is no camera lighting. Yeah. That is pure brass reflecting the beam. You can already tell it is going to be a beautiful cut. As we move along, watch the edge. Clean, golden, crisp. No oxidation, no burns, no burn marks. Just the premium finished brass is known for.
Yeah. Wow. That looks really gorgeous on camera. I bet people in the comments are loving this one, right? So if you've ever cut brass before, type BR in the chats. And also let's see how many brass fans we've got.
Yes, brass always gets a big reaction. And just like with aluminum, make sure your focus and gas flow are stable. That is the key to getting that perfect glossy edge. One more quick tip. Brass is a reflective material, so a clean protective lens and steady nozzle pressure make a big difference. Small details, big results.
Awesome. That wraps up our cutting demo, but don't go anywhere. We've still got something really cool laser technologies to show you. We are going to walk through 5 technologies. Like the first one is marking, laser marking. The second one is countersinking, and the third one is bevel cutting, and the third one is air cutting, and also the last one, the super fast flying cutting. Let's kick things off with the first one, laser marking.
Laser marking, Dennis, is basically using a concentrated laser beam to engrave or mark directly on the surface of your material. It is clean, precise, and permanent. And the best part, it solves a lot of common problems in manufacturing. Unlike ink or stickers that fade or peel off, laser marks stay sharp and readable for years. It also gives you super clear and detailed results.
Okay.
Yeah, even tiny text or QR codes come out crisp.
I see. Well, I think laser marking can also be used for logo engraving, right? And also branding marks and all kinds of decorative patterns. It's also great for signage, crafts or custom metalworks. And in the sheet metal workshops, marking bending lines is a huge time saver. Operators bend faster and with better accuracy. Plus, it's also ideal for tool or components labeling, and even products customization for small batch of or personalized orders. So laser marking isn't just a nice-to-have feature. It's one of the most practical, widely used laser processes in modern metal fabrication.
Amazing. And since Christmas is just around the corner, we thought we would add a little holiday flavor today.
Yeah.
We will be marking Bodor Laser and Merry Christmas Live. You will see the message appear in just a few seconds. Now let's play the marking video.
Okay, let's go.
Amazing! Next up, countersinking. This process uses the laser to create a small recess or depression on the surface. It is mainly for screw or nut installation, so the connection surface stays smooth and perfectly flat. And it actually solves a lot of real problems in sheet metal assembly. No more screw holes sticking out, no more uneven surface, no more scratching or snagging.
Yeah. And also countersinking is one of these simple but incredible useful. Its applications are everywhere in real production. For example, you can use it for screw seating or nut installation, so the fasteners sit lines and flush with the surface. It's also great for flush mounting, assembly preparation, and precision component fitting. Anytime you need the connection surface to stay smooth and clean. And also in fabrication, countersinking is often used for pre-welding preparations and mechanical fastener positioning, making the next process faster and more accurate. So even though the features look small, the impact on the assembly quality is huge.
Right. It also adds part lean better, and it makes the next steps, like bending, welding, or handling, much easier.
Yeah.
Now let's play the countersinking video.
Okay, let's go.
What's this? The laser gently melts a circular pocket right where the screw will go. It is quick, precise, and you do not need any mechanical drilling.
Yes.
All right. Now, here comes one of my favorite, bevel cutting. Bevel cutting. This is where high-power lasers really shine. We are using our 30 kilowatt setup here to cut stainless steel at an angle. Bevel cutting creates angled edges like 30 degrees, 45 degrees for weld preparation or special joining.
Okay, right. Bevel cutting is really a game changer when it's come to welding and structural fabrication. You can see it used in a ton of real-world applications. For example, it's essential for weld preparation, especially when you're creating V-type, X-type, and also key-type joints like on thick plates. It's widely used in the thick plate welding, structural steel fabrication and pipe or beam drilling. Any well strong, high quality welds are needed. And you can also find bevel cutting in heavy machinery components, shipbuilding and marine structures, and even construction and bridge engineering. So once you have bevel capability, your fabrication shop can take on much bigger projects with higher precision and stronger joints.
And it actually solves a lot of welding and fabrication problem.
Yes.
You get stronger welds, you get stronger welds, better pressing, and a cleaner fit up. No more slow manual grinding, no more inconsistent angles, and way less prep work before welding.
Yeah.
All right, let's take a look at it now. And look at that, a perfect bevel, smooth edge, no rework required. That is serious productivity.
Yes.
Now let's switch gears a bit. This is hair cutting. Instead of using oxygen or nitrogen, we are using compressed air as the gaseous gas. The idea is simple: reduce cutting cost while keeping good cutting speed and quality.
And air cutting, the most convenient advantage of air cutting is it's very cheap to get. It has become a super popular lately and for good reasons. It gives you a very big advantages. First, the gas cost drops massively because you are just using compressed air, no expensive nitrogen needed. It also performs really well on thin carbon steel and stainless steel, giving you the clean edges at a high cutting speed. Another advantage is that air is also very eco-friendly. Like we don't need to pollute the environment, and easy to access. So you don't have to worry about gas supply issues.
Yeah.
And also overall, it helps you cut down your operation costs while still keeping solid cutting performance. If you want faster cuts and low cost air cutting, may be a very good option.
Yeah.
So and also let's take a look at a short video.
Yes.
About air cutting.
All right, to wrap up this section, here is a really fun one, fly cutting.
Okay.
This is all about the speed and efficiency. Instead of stopping between cuts, the laser head keeps moving while cutting multiple shapes continuously, almost like cutting on the fly.
Fly cutting, that's a very interesting name, right? I can explain you guys of how we can use fly cutting. Fly cutting is all about the speed. It absolutely shines on thin sheets within 3 millimeters, and whether it's whether it's carbon steel or stainless steel. If your shop does mass production of small parts, fly cutting can boost your efficiency by a huge margin. It's also ideal for perforated plates, decorative patterns, ventilation holes, and all kinds of repetitive shapes. Industries like HVAC, electrical enclosure, control panels, metal screens, and decorative panels use flying cutting all the time because it's fast, convenient, and incredibly efficient. So if your production relies on high-speed, thin sheet cutting, flying cutting is a game changer.
Yeah, and it solves several big productivity problems. You eliminate constant start-stop motions. You avoid slow acceleration and deceleration. And you get much faster cutting for repeated small shapes. Yeah, it also reduces heat build up and lowers the cost per part in batch production. You will notice the motion almost looks like the machine is dancing. And the cutting speed is incredibly high. Look at it. Look now. Look now. All right, that was an amazing showcase. 5 different processes, 5 different use cases: marking, countersinking, bevel cutting, eye cutting, and the fly cutting. Yeah. It's one showing what Bodor Laser technology can do in real-world production.
That's very fantastic. Next up, we've prepared something very. We prepared a case, a customer story for our audiences. We are taking you inside a real European factory to show how Bodor machines perform in everyday production. Not theory, not simulation, but real work on real shop floor. This customer story comes from Sovistol, a well-known metal processing company in Poland. They've been in the sheet metal industry for more than 20 years, supplying cold-rolled, hot-rolled, coated steel, and aluminum sheets across Europe. And what's really impressive is that their production line runs Bodor high-power P-series machines every single day, long hours, heavy workloads. It's a great example of real industrial performance. In this video, you will see how they manage large volume cutting that challenges the challenges they face, and how high-power laser technology helps them achieve both precision and efficiency. All right, let's jump right.
At the moment, we have 6 fiber lasers. 2 of them comes from Bodor. First one, P12, was fully installed in 2024. The second one, P6, with working table 2x6, but with the iTrans system, is already during the installation process. My name is Piotr Wysocki. I'm director of Servistal Metal Forming Center. Servistal is the biggest independent steel service in Poland. As a company, we deal with processing of flat products, stripes and sheets, cut to precise size in accordance with individual needs of our clients. In 2023, we analyzed the market needs, and with a decision of our board and president, we decided to invest in machinery park for additional processes like laser cutting, bending, and forming, etc. For over 2 decades, we have been efficiently executing even the most challenging orders from our clients. business strategy of Servicetal is building and maintaining the long-term relations with our customers. We operate in such a way to assure that every client, regardless to the scale, has the feeling of safety, satisfaction in cooperation with us. At the moment we have 6 fiber lasers, 2 of them comes from Bodor. First one, P12, was fully installed in 2024. It has a power source of 20 kilowatts and working table 2.6 by 12.5 meters length. The second one, P6, with working table 2 by 6, but with the icon system, is already during the installation process. That would be the first one in our factory with a bevel head inside of it. After the visit in China, where we had the opportunity to see for ourselves how the Bodor deals with the production, responds for the individual customer needs, and what's the most importantly, potential of growth. Overall, I am satisfied with the Bodor Laser service. The sales team was very professional during the negotiations. The after-sales team was very responsible and helpful. A bit more proactive follow-up after the installation process would be helpful, but I'm generally pleased with the experience. My wish is for a long-term partnership with Bodor, including regular software updates, update options for existing machines, and feedback sharing.
Bodor, Dare to Dream.
That's a great video, right?
Yeah.
It's always inspiring to see some real factories using Bodor equipment day after day.
Yeah, and what really stands out is the stable quality during long cutting runs, the speed boost compared to their previous machines, and the precision they achieve even on complex parts.
And of course, easier daily operation and real savings in gas, labor, and maintenance. That's what every factory wants.
Yeah, a big thanks to our customer from Poland, Servicetal team, for sharing their story.
All right, that was awesome. And before we continue, a quick reminder to thank everyone for joining us today. We are offering a special sales live stream later this month with our best offers of the year. If you want to claim your exclusive webinar discount, just send global #1 to info@bodor.com. We will send you details ahead of time so you won't miss out. Now, we covered a lot today. Parameters, logic, real cutting demos, process, showcase, and even a customer story. Before we wrap up, let's answer a few questions from our chats. Let's see. I think the most common one is, how can beginners learn to set right cutting parameters?
It is actually pretty simple. All Bodor machines come with the smart parameter auto match. This during cutting automatically recommends the best settings based on your material and thickness. So even if you are new, you can start cutting right away with sensible parameters. No guesswork, no long trial and error loops, just fast and accurate setup every time.
Wow, that's very impressive. And another interesting one from the chat, how do you keep small parts from tipping, moving or falling during the cutting?
Yeah, great question. That is exactly why Bodor developed nano joint technology. Nano joint technology. Instead of cutting the part out completely, the machine automatically leaves tiny traceless micro connections. They are almost invisible, but strong enough to keep the parts stable. So it won't tilt, pop up, or hit the cutting head.
Yeah, that's really clever. No more parts flying around and causing collisions.
Yeah, exactly. And because the joints are very tiny, the edges stay clean.
Yeah.
Yeah, you can remove the parts easily afterward, usually without any extra grinding or polishing. It's super helpful for thin sheets, small parts, and precision jobs. Because the joints are so small, you can remove the parts very easily afterwards, often without any extra grinding or polishing. This is especially useful for thin sheets, small parts, and precision components, where even a small collision or a movement could ruin the workpiece or stop production.
I've seen another questions in the comments. So how do I know if my cutting speed or focus position is correct? I think you have just explained us before.
Yeah, here's a very simple trick. Watch the sparks and check the cut edge. If the sparks drop smoothly down and the edge looks clean, you are in the good zone. If the sparks scatter, tilt, or the edge shows drops of burning, then it's time for some fine-tuning or speed or focus.
Okay, I see. That's very super practical. And let's move on. Here's another big one, warranty.
All three core components of Bodor machines come with a 5 years warranty. So you can cut with confidence and focus on production. On top of that, our engineers provide 24/7 after-sales support to help you minimize downtime and keep your operations running smoothly.
Perfect. So to recap, today we explore how to understand the basic of laser cutting, how real parameters work on actual materials, and how to make your laser cutting smarter, faster, and more consistent.
And exactly, exactly, Dennis. That is what Bodor is all about. Making advanced laser technology easier and more efficient for everyone.
Yeah. And once again, don't forget to our special sales live stream comments.
Yeah.
It's in December, later in this month. If you want to secure the giveaway, send global #1 to info@bodor.com to claim the webinar discounts and get the event details in advance. And make sure to follow our accounts in social media on Facebook, YouTube, and LinkedIn for more live demos, tutorials, and updates. And all right, everyone, that is for today's Bodor Laser Academy Live. See you next time.
Streams, boundaries are removed, and ideas are inspired. Bodor will build a pivot for the laser application of tomorrow, and the largest laser cutting and welding equipment production base will rise. Bodor is clear that it is a time for steering the course of a